So I will start my class today, and I will continue in this ecological community. And the first part which I will be taking actually is going to be diversity indexes. I did not take up that community that part of ecological community. So I will present my screen. Is the whiteboard visible to everybody?
Yes, sir.
Okay, very good. So today we will be talking about diversity index, plural indices. So essentially this measures the species diversity. It's a measure of species diversity in an area, basically. Measure of species diversity in an area. So there are two main types of diversity indices. The first one is known as the dominance indices. Dominance index or indices. And the second one is known as information statistic index. Information statistic index. So let us talk about dominance index. So dominance indexes, they are weighed towards the abundance of the commonest species. Just hold on, somebody is trying to enter. So dominance index, actually it is weighed towards, somebody is entering. Dominance index is weighed towards weighted towards abundance of the commonest species. Commonest species. So among these dominance index, a widely used dominance index is the Simpsons diversity index. Simpsons diversity index. This Simpson diversity index, it takes into account both the species richness and species evenness. So how many how many different types of species are present, and how many of each species are present. So Simpson's index is D. Index written as D. It measures the probability that any two individuals drawn at random what it does, it measures probability that any two individuals drawn at random from an infinitely large community, ecological community will belong to the same species. So let us see, this is an area where there are a lot of animal species living. So this green dots maybe are one species. Let the red dots be another species. Blue dot another species. Pink dot another species. Yellow dot another species. So the question is, what is the probability that you pick any two species, any two times you pick any two, not any two species, pick any two individuals. Pick any two individuals from here. What is the probability that those two will be, say, blue? If the number of blue individuals are of that species blue, if the numbers are more, then that means there is more blue species than more green species. So this is how the calculation is done in Simpsons Index. So there are two versions of the formula for calculating D. You can use any of these two, but you must use it always. First is D equal to summation of sigma. This is summation of small n by capital N whole square. This is where small n equal to the total number of individuals of each species. Of each species, of one species, say, and capital N is equal to total number of organisms of all species. This can also be written as, a better way of writing this formula is D is equal to sigma of small n into small n minus 1 divided by capital N into capital N minus 1. So this is a better way of doing the species. So D is basically it is a probability value. So it the value ranges from between 0 to 1. So 0 represents infinite diversity. That means there are so many all types of the whenever you are picking, you will never find two species of the same thing. 0. So you pick two times, you are putting hand inside that community and picking up two individuals. So what you have to find the probability that both the times here, what is the probability that both the times you are picking the same. So 0 means both the times you are picking different type. First time a different species, second time a different species. So 0 means it has got infinite lot of so high diversity that you will never pick up of the same species. And 1 means 1 represents no diversity. It's only the one type of species is present. In reality, both are not possible. So the values are in between. So now this what we have talked about, this is Simpsons Index. We have talked now about Simpsons Index. Now we will go to Simpsons Index of Diversity 1 minus D. Simpsons Index of one minus D. You can also represent it like this. This index represents that you are doing it the other way around. Index represents the probability that two individuals randomly selected from a community will belong to different species. In the former one, you are in D. D means they will be same species. And 1 minus D means you just subtract the value from 1, that is different species. So what is the probability that 2 times you are picking up, you will get a different species? It's just the other way around. 2 individuals. It's written like this. Then you have another thing known as Simpsons Reciprocal Index 1 by D. The value of this index starts with 1 as the lowest possible figure, because you are dividing it by 1. The value of this index starts with 1 as the lowest. Starts with 1 as the lowest community figure. Lowest possible figure. So 1 means this represents a community containing only one species. So higher the value, higher will be the species diversity. So let us consider an example. Use a red pen and do it. Say species A, B, C, D, E. A, B, C, D, E. Total is N. Number N 28113. 28113. So 2 numbers of A species were seen, 8 number of B species were seen, 1 number of C were seen, and so. And total capital N is 15. If you add all these things, it is 15. And the value N into N minus 1 is total N. So this is sigma N into N minus 1. So 2 into 2 minus 1. So 2 into 2 minus 1, that is 2 into 1 is equal to 2. Similarly, this will become 56. 0, 0, 6. And the total of this is sigma N into N minus 1, that is equal to 64. So now we are going to put this into this Simpsons diversity index value, D value. sigma n into n minus 1 divided by capital N into capital N minus 1, and this will become 64 sigma n into n minus 1, that is 64 divided by 15 into 14. There are 15, n minus 1 is 14. So this will become 64 divided by 15 into 14, and this is equal to 0.3. So Simpsons index is index D is equal to 0.3. This is the diversity index. Now what is the Simpsons index of diversity? Now Simpsons index of diversity is 1 minus D, that is 1 minus 0.3, that is 0.7. And what is reciprocal? 1 by D, Simpsons reciprocal index. What is this? 1 by 0.3, that is equal to 3.3. So that means this has got a good diversity. Lowest is 1. That means no diversity. Now we go to information statistic index. We will go to so information statistics indices, they take into account rare species in a community. This is another way of seeing the diversity index. This is based on the rationale or the principle that diversity in a natural system, diversity in a natural system can be measured in a way that is similar to the way information contained in a code or message is measured. So in an English alphabet, for example, I don't know if you people have read about Sherlock Holmes. In Sherlock Holmes, there is a uh, there is a story known as the Dancing Men. So all these dances, there was a murder taking place, and the murderer wrote on the wall, certain dancing men were drawn. So Sherlock Holmes deduced that these were basically a message or a code which was written about certain factors. So what is the, in English language it is found, he knew that the most common letter in an English language is E. In a sentence, E. So a particular type of code, if it is represented many times, then it is particular, that is supposed to be E. Similarly, this is how it is done. So in a natural community, it is measured in a way, what is the probability that the next species which you will get is a rat, or what is the probability that the next species which you get is a cat. So this is how a particular for a particular species is measured like a code. So that code is zero point 0.3 is the code for a rat, or say 0.5 is the code for a cat. So the moment you see 0.5, you can say, oh, it's a rat. So among them, the first index is you will understand it more clearly after we go through these index, is Shannon's index. Shannon index. So the index value is HS of a species equal to sigma of P I natural log of Pi. I is equal to 1, n you give the set the limit over there. Here where Pi equal to proportion of individuals found in the ith species like species A, species B, species C, in the ith species, the species which you are doing under consideration. What is the proportion of the individuals in the ith species? ln is the natural logarithm. It has got a value. Two point something after 7 or something, 783. Value of ln is. Sorry, value of E is. So log is the natural logarithmic value. You can see a log table, ln of that value. So ln is natural logarithm. Logarithm. So let us look at a table. Species A, B, C, D, E. Here total. So total number of species is 5. Abundance, how many are present? It has been counted. 50 A has been counted. 30B has been counted, 10C has been counted, 9D has been counted, and among E, what is it? 1. So the total is 100. Then what is PI? Is the proportion of this individual. PI. This is 50 by 100. Total is 100. 50 by 100. That is 0.5. Similarly, this is 30 by 100. 0.3. C is like that, 10 by 100. That is 0.1. 0.09. 0.01. And the sigma pi is, if you add these together, it is 1. And if you see the log table and multiply pi into ln into pi, if you see the log table and do it, it's minus 0.347 minus 0.361 minus 230 minus 217 minus 0.0, let's see the log, 046. And if you take the sigma of this whole thing, minus 1.201. Now what is HS then? HS is this value, 1.201. This is the Shannon index. HS is about this. So even here the rare species, which is E, which has got one individual, rare species E, which has visual, contributes some value to the Shannon index. Here, for example, you had 0 in the previous one. Contributes something to index. You see the value is quite high compared to this. Even 1, it is giving something. Apart from that, in this previous indices, diversity indices, you could not find rare species were not represented. Here rare species also give some value to the index. So these are the two indexes which you have to follow. There are other like Brillouin's index, but I don't think you need to study all those things. So these two indexes are the indices which you need to study. After this, I will go to the part which the internet connection went off in the last class, and that is ecological succession. So we will be talking about basically succession. By succession means one community is essentially replacing is replaced by another community. So initially you had a specific community in a barren land. This is a barren land. You had a specific community 1. This is the first community which comes in a barren land, that is known as pioneer community. Then in this this first community then in this barren land gets replaced by the second community. Like this, it reaches on and on and on and on it goes till it reaches the last community, final community, and that is known as the climax community. This is known as climax community. The final community which forms is the climax community. And each of this stage, and say each stage is known as several stages. Essentially, this is ecological succession. Now, if you remember what happened when I joined BB College, an interesting thing happened. I observed it. Very few people had observed that, but I observed it, and I tell my students every year about this when I'm talking about ecological succession. This story, that is, if you enter our college from the GT Road side, on the left side you will see a jungle, lot of trees and jungles and shrubs and birds and small snakes and everything. They are all residing in that area on the left side if you enter. So when I entered in the college, it was a barren land. Then suddenly the rain came, and in that barren land you saw small grasses and little bit of several insects, and all these they started to come over there. Then this grass and insects, they went away. That gave rise to small shrubs, like where you had lots of partheniums starting to grow over there. Then along with that, there came small frogs and small rats and all. They started to enter in there. Then you had small little birds and all. They are coming over there. Then that community went away, and it gave rise to the trees which you see now. Trees and small, and you saw a community succession. You have an understory, you have the floor, forest floor, you have the canopy, you have everything. You have a complete jungle out there. Yeah, you just cannot enter inside. There is really no light falls over there. So now I think that is the final climax community. Now there is an interesting thing which takes place, that is known as this, from a barren land to the final community. This is known as primary succession. Then suddenly one of the teacher in charge there decided that I will construct something over there. Okay, I will construct a canteen or something. He got some nice money from the tender, the vendor and tender and all these things, and so he started the work, and using college funds. And then what he did was he just removed certain a region of it was laid barren, and then what happened, he lost interest, and these people, they did not pay, and all that project got scrapped. And what happened was that some part of that land was cleared. So a disruption happened in that jungle, and that place, maybe it could have been a fire. Here it was, the trees were cut over in one region. Now that particular region that became empty, So you had a forest over here. Suddenly, in this region, this part got cleared up, and what you have left is this was blank. And so here again grasses, that grass and insects started to come inside. And succession started to take place over here. This type of succession, where a fire or accident, something happens and destroys a part of the final climax community, this is known as secondary succession. So the first barren land inhabitation, that is known as nudation. So essentially this finishes ecological community. There are few things about community I need to mention about some types of interaction between species in a community. I have sent a lot of notes over there. So theoretically, populations of two species in a community, they may interact in many ways. That can be neutral, that is the nothing happens, their interaction nothing, or it can be positive, that is they help each other, or it can be negative. So neutral can be written as 0, positive means they are helping each other, plus, and negative is minus. So you can write an interaction between two species in these terms. So there are certain types of relationship in literature. First is neutralism. In neutralism, neither population is affected by association with each other. Is affected by association with each other. Then you have competition. Neutralism happens, then competition. This is fun. It is direct interference. Here, both populations actively inhibit each other. Then we have Emensalism. In Emensalism, one population is inhibited and the other is not affected. is not affected. Then we have commensalism. In commensalism, one population is benefited but the other is not affected. And the other is not affected. After commensalism, we go to parasitism. One population is benefited and one suffers. One population suffers. Then you have predation. In which one population adversely affects the attack by direct attack. One population adversely affects the other by direct attack but nevertheless depends on the other. This is surprising. For example, deer and lion. So the lion attacks and kills the deer and eats them. But funnily, even the deer is dependent on the lion, because the number of the deers, if they increased a lot, if there were no tigers or predators, then problem would be that there would be no grass left. They would have eaten all the grass and then they would start killing and start all disease and all these, their numbers would increase and there were a lot of competition and all these things would arise. So the lions do them a favor by controlling the number. So this is where therefore this is where the dependence on predation is there. Therefore it is selected, predation is selected. Then you have proto-cooperation. Here both populations are benefited. But the relation is not obligatory. नहीं भी कर बिना without that association they can still survive. It is not obligatory. And then finally you have mutualism, in which both populations are benefited, growth and survival, important for because of this association, and this is obligatory. One cannot survive without the other. So after this, this essentially ends your ecological succession. Remember also to read Gauss's laws. Complete competitors cannot coexist, and this paramecium chordatum and paramecium aurelia example, this thing, definitely don't forget to read all these things. So with this I stop my sharing. Do you people have got any questions? কোনো question আছে? No sir, अच्छा. Were you people able to hear me? तुम लोग को सुनाई दिया था? Okay, okay, fine. Then I will tell you again when the next class. Possibly I wish to take it tomorrow, but I will confirm it once in the at around 5 or 6 in the evening. I will confirm at 8 o'clock. I will take another class. So I will start with let's see where the next topic which is remaining, the protozoa part, which we must study. That part needs to be dealt with. Okay, then I am if you don't have any questions, I am ending this class. Bye bye then. Okay, class खत्म कर रहा हूँ. Hello. Okay.